The original source of energy is what? The sun. Then plants use the sun's energy during photosynthesis to convert water and carbon dioxide into sugar and oxygen, and they store the energy in the chemical that the plant produces. When animals eat plants, their energy is transferred to their bodies. So then, the plants and animals die and decay, and they sink to the bottom of the sea or disintegrate into the soil. Disintegrate into the soil, and then they are covered by more and more sediment as rivers deposit mud and sand into the sea, or the sea's advantage and retreat. Huh? Or the sea's advance and retreat. Of course, it's a very gradual process. One that takes place over, well, millions of years. But finally, the organic materials begin to transform into the hydrocarbons, and the hydrocarbons eventually become oil and gas deposit. I think it was this. Mm-hmm. Okay, I think it was. So how does this happen? Well, at first, the oil and gas are mixed with sand and sediment, but as the layers on top increase, then so does the pressure. And under pressure, mixtures of oil and sand and water, they seep down through the layers of porous rock. That's usually sandstone or limestone, so they sink down until they reach a layer of non-porous rock, and that's where they pour because they can't pass through the non-porous rock. Hmm. 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 Okay, sometimes there are breaks in the layers of rock, and the breaks allow oil and gas to bubble up, and eventually they reach the surface of the earth again. So when this happens, the gas and some oil evaporate into the air, but they leave a sticky black towel that appears in pools or pits or the surface. But most crude oil is found in underground formations, which we call troughs. So today I want to talk about the major types of oil troughs in all different types of troughs. The oil collects in porous rocks along with gas and water, and over time, the oil moves up toward the surface of the earth through cracks and holes in the porous rock until it reaches a non-porous rock deposit. And the non-porous rock, remember, it won't allow the oil to continue moving. So the oil becomes trapped under the non-porous rock deposit. Now think for a moment. While oil was forming and moving, the earth was also undergoing changes. In fact, there were enormous movements of the crust as the center began to cool. Crust as the center began to cool. When holding happened, fold happened. Well, it was like the earth fell back onto itself. And when folding happened, fold. Folding happened. It was well one layer was forced by rocks above down through the layers below. So you can see that the repositioning of porous and non-porous rock. This repositioning would have affected the movements of oil. When the earth shifted, the cracks would have been opened and non-porous layer would have been dropped over channels that had previously been used as a pathway for the transfer of oil and gas to surface. Okay, as geologists, we are interested in locating the traps. Now, why would that be so? Because that's where we'll find the oil and gas reserves. And that's what I really want to talk about today. So, there are several different types of traps. But today we are going to talk about the three most common ones: the anticline trap, the salt dome trap, and the fault trap. Look at this diagram. Here's an example of an anticline. As you can see, the oil is trapped under a formation of rock that resembles an arch. That's because the arch was bent from a previously flat formation by uplifting. In this anticline, the petroleum is trapped under a formation of non-porous rock with a gas deposit directly over it. This is very typical of an anticrine because the gas isn't as dense as oil. It rises above it. The dome over the top can be rock, as in this example, or it could be a layer of clay. This important thing is that the cap of non-porous material won't let the oil or gas passes upward or sideways around it.